Hello, student. In previous lecture, we have learned how we can write assembly language, simple assembly language program to add two 8-bit data or two 16-bit data and to subtract two 8-bit data or two 16-bit data. Now, in this lecture, we will study similarly how we can write a simple assembly language program to multiply two 16-bit data or to divide a data. So, uh, this is a program for multiplication of two 16-bit data. So again, the data which have we have to multiply should be loaded into the microprocessor register. So again, by using move instruction, first we will load one 16-bit data in register AX. So for this, we will write move AX comma 1234H. So given this instruction, the first data of a multiplication will be available now in register AX. And similarly, we use move BX comma 5678. This 5678H is the other 16-bit data, so which will be loaded in register BX by using move instruction. So now two data are available in AX and BX register. The other two 16-bit data which we have to multiply. Now here we will give for multiplication we will use opcode MUL. MUL opcode is used for the multiplication and only one data, one register is given here. So it should be remembered that for multiplication, one data should automatically stored in AX register. One data should be stored in AX register for in case of 16-bit multiplication. It is necessary condition that one data should be stored in AX register and another 16-bit data can be stored in any general purpose register of the microprocessor like VX, CX, DX, etc. So here one data is we have to store one data in AX register and another data is in VX register and given MUL VX. So this instruction will equivalent to the multiplication of AX automatically when you will this instruction MUL VX AX register will be taken by default. So the AX is multiplied by the VX. The contents of AX register is multiplied by the VX register. And in multiplication, when we multiply two 6-bit data, it can be assumed that data should be greater than in mostly cases data will be greater than 16 bit. So it can be assumed that greater than 16 bit means data will be 32 bits. So low order 16-bit data, in case of 32 bits, the low order 16-bit data will be stored in AX register and high order 16-bit data will be by default is stored in DX register. So the result will in case of in multiplication of two 16-bit data, result will be stored in two register AX and DX. So the lower order 16-bit result will be stored in AX register and the higher order 16 bits result will be stored in DX register. Now this result can also be transferred to the memory location again by using the move instruction. So here the move instructions move square bracket 2050h square bracket 2050h represents the memory. 2050h is the memory location. So the contents of AX register will be transferred to the memory whose address is 2050h by using move instruction. Again, by moving move instruction, the contents of DX register will be transferred to the memory location whose address is 2052H. And after storing the result, we can write end of the program. So this is equal to the end. Halt is the end of the program. So here we can simply write multiply of 260-bit data, program of multiply of 260-bit data. So for multiply 216 data, one data should be stored in compulsory in AX register and another 60-bit data can be stored in either in any general purpose register of the processor and by giving MUL comma another the address of the second data. So address of the second data can be VX, CX or DX. So when you will give second data, automatically AX will be multiplied by the contents of second register. So this is the simple program of the multiplication. Now again, in division operations, how we can write operation of division for division. So in division operation, it is necessary condition that the data which has to be divided will be greater than the data by which we have to divide. For example, uh, suppose we have to divide A upon B. We have to perform this operation A upon B. So for in 806 microprocessor, it is necessary condition that A, data A, should always be greater than the data B. It is the necessary condition in division operation. So in keeping mind, A should be, if A is the 16 bit, then B should be 8 bit. If A is the 30 bit, then B should be 16 bit. In this way, the A will be always greater than B. The size of A will be greater than the size of B in for division operation. For division operation again. So the data which has to be divided will be automatically should be stored in the accumulator register, and AX is the accumulator register. So just like in multiplication operation, the data which has to be divided should be stored in accumulator register. So suppose 1234H data has to be divided by 03H. So 1234H will be stored in AX register. Now the second data will be stored in any 8-bit register. So here VL, we have taken 8-bit register. 03S is the 8-bit data, will be stored in 8-bit register. Here we will, for division operation, we will write div VL. So div VL will be, this operation will be equivalent to the AX divided by VL. This operation is equivalent by AX divided by VL. So when we will this instruction div VL, AX will be divided by VL, and division operations, we know that there are two results. One is known as the quotient and another is known as the remainder. So the quotient will be stored in AH register of AX and remainder will be stored in the AH register of the AL. So the real will be stored in two parts in the accumulator, where the AL keeps the quotient and AH keeps the remainder. So these two results will be available after the division operations, and now these results can again be stored at the memory location by using move instructions. So where move instruct by using move instructions, the quotient is stored as the memory location 2050H, and the remainder will be stored at the memory location 3050H. And again, like other program, we write halt, HLT halt instruction at the end of each program. So this will be the simple program of the division operation of two data in assembly language form. So thank you.